Hello everyone, welcome to today's tutorial. Today we are going to talk about solutions of Gaussian elimination. So we have three different kinds or three different cases in this. We can say that we can have one solution when you solve a Gaussian elimination. We could also have infinitely many solutions. So you can say infinitely many solutions. And the third case is we could have no solutions at all. Or you can say no solution. Yeah. So in this section we are going to discuss the first case, that is having one solution. So we're going to take an example of linear systems and solve it and see when do we have only one solution. Okay, so let's go ahead and start working on that. Let's go with case 1 now. That's one solution. Now we have, let's say, two linear systems, that is 3x1 plus 2x2 is equal to 2, and we have x1 plus 4x2 is equal to 3. So now we'll write these two linear systems as augmented matrix. So we'll write it as augmented matrix form. And that will look like 3 from x3 x1 and 2 from 3x2 x2. So that will be here, and here you have 1x1, so we'll write it as 1 here, and here we have 4x2, so 4, and separated by we have 2 and 3 in vector B. So that would be the augmented matrix for us. And now we will try to do the row operations to make it in the row echelon form, and then we'll try to find out the values, or you can try to find out our solution. So I'll copy this one. Here. Now, the first row operation that we can do on this one here is we can multiply row 2 with -3. Okay, and maybe I'll just write it like this here. So we multiply -3 to row 2, and of course we'll put the values to row 2. So that would give us here, so row 1 we did not change anything, it remains as it is. In row 2 we have multiplied -3, so -3 times 1 is -3, -3 times 4 is -12, and -3 times 3 is -9. Okay, now the second row operation that we need to do for making it a row echelon form is we have to make this element to 0 over here now. So what we can do here now is we can take the row 2, add it to row 1, and put the values to row 2. In that case, now we're not changing row 1, so again it's 3 2 2 here, and for row 2 now we'll add row 2 with row 1 and put the values to row 2. So -3 plus 3 is 0, -12 plus 2 is -10 here, minus 9 plus 2 is minus 7. Okay, so now it's in the row echelon form, our augmented matrix, and we can work out the solution vector. So we will now take minus 10 times x2 is equal to minus 7. So here, this here is for x1 and this one is for x2. So yeah, then we have 0 times x1, which I'm not writing it down, and here we have minus 10 times x2 is equal to minus 7. So you can say x2 is equal to minus 7 over minus 10. The minus will cancel here, so you have for x2 the solution is 0.7. So we got one value, and now we'll work out the value for x1. So we'll take the first equation here, which will be 3 times x1 plus 2 times x2 is equal to 2. So here 3 times x1 is equal to 2 minus 2 times x2, which we have the value here, that's 0.7. So here, if we are left with x1 and we calculate the values here, you have 2 minus 0.7 times 2 is 0.14, and here the 3 was multiplying, so it will come and divide here, and then we can say the value for x1 is equal to 1.86 divided by 3. Okay, it's not very visible here, I guess, so I'll just rewrite it beside it. So this is equal to 1.86 divided by 3, and that's the value for x1. So you can say that the solution vector for us is equal to 0.7 comma for x1, and x2 is 1.86 divided by 3. So we have, as you can see, we have one solution or one unique solution to this system of linear equations that we solved in this section here, and that's the end of this section.